Hey guys, so I'm going to go through this review and I'm just going to get as far as I feel like getting because I'm starting pretty late. Um, all right, this is the whole chapter, so this goes back to the stuff that was on the quiz. We're doing vertical and horizontal asymptotes. This is the first format we learned where there's a number on the top, no x. When you have that scenario, you're going to get your well, this is always how you get them. You're going to get your vertical asymptote by whatever makes this bottom equal 0. So in this case, that would be a 4. So my vertical asymptote is actually a vertical line. And so you write it as x equals 4, not just 4. 4 is a number, not a line. And then horizontal asymptote is going to be from this because, as we know, a number at the end of a graph moves it up or down. So this is going to go down 2. So that's always going to be my horizontal asymptote value in this formula. And if there's nothing there, your horizontal asymptote is y equals 0. So mine's y equals -2. Okay, so then this is the other kind of problem because you can see that this does have an x on the top and the bottom. So in that scenario, I still am going to see what makes the bottom equal 0, and that is still going to turn out to be my vertical asymptote value. So this one's at x equals -5/3. And again, I write the x equals and then the value. Horizontal asymptote is where I compare the top and the bottom. And in this case, my top power is 1, my bottom power of x is 0. So since they are equal, that is a scenario where I use the ratio of the coefficients. So in this case, the x's would cancel, and -12 divided by 3 turns into -4. So that y equals -4 will be the location of my horizontal asymptote. Why do I need to graph 2 of these? I'm not sure, but let's go for it. Okay, this is my horizontal asymptote. That will determine my range also. So because my horizontal asymptote is at -2, which I need for graphing, because I have to actually graph it in there, my range is going to be any y's that are not equal to that number. So my asymptote and my range are the opposite of one another. One says it's equal to -2, one says it can't be. The vertical asymptote, again, is going to come from the bottom. So what makes x minus 3 equals 0? And the answer is 3. So I'm going to have a vertical asymptote at x equals 3. So then my domain is x's that are not 3. Because again, they are going to be opposites. So at 1, 2, 3, crossing the x is my other asymptote. I like to put the vertical asymptote number in the middle of the table. Then I do 2 numbers before and 2 numbers after. And to be honest, you really could do just 1 because you only need to know which side of the asymptotes. Oh, that's my dog making weird noises before she lays down. She sounds kind of like a whale. Anyway, you only need to know where the dots are above or below the horizontal asymptote, and then you're good to go. If you're going to put this in your calculator, make sure all of this ends up in parentheses so it knows that the bottom is all together. And then this x is going to be what you replace here. You can't use 3 because 3 will make the bottom 0. You get an error. But let's see. What if I use 2? That'd be -1. So that's be -3. And then if I used 4, that's be a -1. Here's why that's enough. If I go to 2 and then down to 1, 2, 3, I know that my graph has to be on this side. And it follows along those asymptotes. If I go to 1, 2, 3, 4, down 1, then I know that this branch is going to go up here, which I kind of already knew because they're always diagonal to each other, kitty corner. So it's really enough to do just 2 points. Okay, here again. This is going to be my horizontal asymptote value, and it's going to mean I have a horizontal asymptote at y equals 1. Therefore, my range is everything except 1. And so I draw in my horizontal asymptote at 1. On the bottom, my vertical asymptote is whatever makes this equal 0, and so that's going to be -2. Since I have a vertical asymptote at x equals -2, my domain is any x except -2. Put it in the middle, number to the left, number to the right. You can do more if it makes you happy. You will not get an answer for that. Oh, I forgot to draw my vertical asymptote in. My vertical asymptote is at x equals -2, so it only crosses the x at -2. Alrighty, so if I plug in a -3 for this x in my equation, I'm going to get a -1, I believe. And if I plug in -1, I'm going to get a 2. So if I count from the origin to -3 down 1, then I know that this branch lands in here and stays inside the asymptotes. And then if I go to -1, +2, kind of happy to see that it pops up into that other section because they're, again, going to be diagonal to each other. Okay, multiply or divide. All right, so this is just going to be where you cancel. Well, this doesn't have any plus or minus in it, so I won't have to factor. What I like to do is to put the number, I collect any x's I have on the top, and then like here, I had 1y and then 3 more, so that's 4. On the bottom, I would have my 15, and then I have x to the second and another x to the second, so that's 4 of those, and then a y to the second. And then I can look at it as numbers, x's, and y's. So 5 over 15 reduces to 1/3 like it always has. Here I would have 1 extra x on the bottom because there's 4 on the bottom and 3 on the top. Here, the difference between 4 and 2 is 2, but because I started with more on the top, that's where it's going to end up, having those 2 extras. And you don't really need the 1 in this problem, but it's not wrong to have it either. Now in this problem, I have adding and subtracting, so I'm going to have to factor if I can. Anything with a plain x that doesn't have a GCF, you can't factor, but this bottom part, I can, because I can take out 4. So if I take out a 4, that will leave me with x minus 4. How about up here? I can take out a 2, but that still leaves me with this, and that's the difference of squares, because this is the square of x, this is the square of 4. So I actually end up with 2, and then x plus 4, x minus 4. Down here, also the difference of squares, because this is the square of x and this is the square of 5. So I get x plus 5, x minus 5. So after I have everything factored, I'm looking for any factor on the top that matches on the bottom. So this whole x plus 4, whoops, doesn't really cancel. JK. It's the x minus 4 that's going to cancel. This x minus 4 and any x minus 4 on the bottom. Here I have an x plus 5 and an x plus 5 on the bottom. On the outside I have a 2 and a 4. So that'll reduce like it always has to a half. So that'll cancel and this will become a 2. So the only thing I have left on top is x plus 4 with or without parentheses. It doesn't matter. On the bottom, I have this 2, and then I still have an x minus 5. So then this is going to be my final answer. In 7, I'm actually dividing, and the difference there is that I need to flip the second fraction over. So here I have 8x squared y squared z over xz cubed. Now I'm going to multiply it by the reciprocal. So the bottom goes to the top and the top comes to the bottom. Then, like I said earlier, I like to kind of do the top. So there's 8. I have x to the second, but 4 more over here, so 6 total. I have y to the second and none others on top. But here I have a z to the 1 and a z to the 1, which is z to the second. On the bottom, for numbers, I have a 10. For x, I have 1 here, so that's 2. I have just 1 y here, and then I have z to the 3. And now I can go through. I didn't have to factor anything because I didn't have adding and subtracting. Looking at the number part, 8 over 10, they can both divide by 2, so I get 4 over 5. Looking at my x's, the difference between 6 and 2 is 4, and those extras will be on top because that's where I had more to begin with. Here I have y to the first and y to the second, so that will put 1y on the top because the difference is 1, and that's where the extras would be. The difference between 2z's and 3z's is also 1, and that's going to go on the bottom because that's where the extras were to begin with. So that is my answer. Here I am going to have to factor again, and I'm going to also have to flip. So here I'm going to my blue card, and I'm looking for something that makes 32 in a way that adds up to 12. So I'm going to find 8 and 4. To get a positive 12, I'll need plus here and here. Down here, that's looking like GCF. I'm going to take a 6 out and leave myself with x plus 7. I'm going to flip, so this is going to end up on the top. That is the difference of squares with square roots being x and 7. So I end up with an x plus 7 and an x minus 7 on the top. And then this is going to come to the bottom. These flip. And I have a GCF or common factor there of x. Pull that out, leaves me with x plus 4. Now that that one's flipped and they're all factored, I just go hunting for what cancels. X plus 4 cancels x plus 4. X plus 7 cancels x plus 7. So I have left on the top an x plus 8, an x minus 7, and on the bottom I have a 6 and an x. And they're on the outside of parentheses, so they could only cancel other stuff that's on the outside of parentheses. So I'm done. All right, let's see. I did this one in class for my kids, so I'm going to erase that for now. That's a lot. I'll do a couple of these. Maybe I'll stop when I get to solving. Let's see how we go. All right, adding and subtracting requires a common denominator, so I'm going to get one. So look at the numbers here. 5 and 6 both go into 30, and then if I put an x, that takes care of these two. So the way I always think about it is like, what do I have to multiply 5x here to turn it into 30x? And the answer is 6. So then that means whatever was above it needs to be adjusted by 6 as well. Then there's a plus and a 7. To turn 6x into 30x, I'll need to multiply it by 5. So I do the same to the top. So I have a common denominator now of 30x. 12 times 6 is 72, I hope, plus 35. And now those are both just numbers, so I'm going to get 107 over 30x. I can check on my calculator to see if that reduces, but I don't believe it does. Okay, here I'm going to get a common denominator. For 3 and 4, they both can go into 12. And 1x is not enough. Well, that's going to fit for that. This one needs a second one. So in order to make 3x squared into 12x squared, I'll need to multiply it by 4. So I'll take the top of that fraction and multiply it by 4 as well. Subtraction sign, then I got a 5. 5 is over 4x, and for 4x to be 12x squared, I have to multiply it by 3x. So I multiply the top, which is the 5, by 3x. So on the top, I have 32 minus 15x all over 12x squared, and I'm done because I can't take anything out of all three corners. Like I can't get this x and this x to cancel because I don't have one over here. It's got to come out of all of them. Here, I'm looking at really totally different bottoms, and so I end up just collecting those as my common denominator. Same thinking. 9 was already over this x minus 3, so it would have to get multiplied by an x plus 1 on the bottom. But that means you're going to multiply that on the top as well, because the 9 was over the x minus 3, but not the x plus 1. Then moving over here, the 2x is already over the x plus 1, but it's missing the x minus 3. So that's what I ultimately will multiply that top by. Now I'm going to go ahead and do the math on the top, which can be foiling, distributing, combining. This is distributing. And then I need to distribute the 2x as well. So I'm going to put that in order. I'm just working on the top and kind of honestly ignoring the bottom for right now. 9 minus 6 will be plus 3x, and then plus 9 all over, and then I bring that down. So once I have the common denominator, I don't really do any math with it. I just let it sit there till the end. All right, this can factor into 7 times 2, and then to get the 5, I'll need a plus 7 and a minus 2. This is already x minus 7. So when I go to do this as a common denominator, I need an x minus 2 to accommodate this, but then I need an x plus 7, which they already have in common. Now the top left is x squared minus 5. It is already over both pieces of the denominator that I'm using, so I don't have to adjust it. Then I had a subtraction sign, and then I had my x plus 3 up here. This one's already over the x plus 7, but it is not over the x minus 2, so that's what I'd have to multiply down here, which would make me multiply it by up here. So I'm multiplying it by whatever it was missing in its bottom. This one's kind of hard on the math end, just a lot to do, because I end up with this x squared minus 5 minus, and then I have to FOIL this whole thing. So x squared is f, and then the outside, the inside, and the last. And I'm just working on the top right now, ignoring the bottom. So I can put these together, and I'll have x squared plus x minus 6. And then I have to distribute the negative, still just working on the top. So I have this minus x plus 6, because as that negative distributes, it changes the signs. Here, these cancel, and I end up with negative x, and then 6 minus 5 is just a plus 1 all over. And since I'm finally done with the math on the top, I can bring down my common denominator and be done. All right, so I'm going to leave it at that for tonight, and then I will make another video for solving and the word problems. So hopefully that helps you get through at least that chunk. Bye, guys.